In this video, we're going to discuss Raoult's law. Raoult's law tells us that the vapor pressure of a solvent in a mixture is weighted by the mole fraction of the solvent that's in the mixture times whatever the vapor pressure of a pure solvent is when it's not in a mixture. So here is the vapor pressure of our solvent if it's in solution. Over on the right-hand side is the vapor pressure of our pure solvent alone when it's not in solution. And then lastly, chi is our mole fraction of our solvent. We know that the vapor pressure of a solvent decreases when it becomes part of a solution, and we can quantify that change or depression in vapor pressure by expressing delta P. Delta P is the change in vapor pressure from our pure solvent alone compared to our solvent in solution. And what's more, we know that the mole fraction of solvent plus the mole fraction of any solutes in solution must give us 100% of the total solution's concentration. In other words, the mole fraction of our solvent plus the mole fraction of our solute equals 1. And rearranging this equation, the mole fraction of our solvent could be expressed as simply 1 minus whatever the mole fraction of our solute were. All right, so that means, pulling in equation number 1 up at the top, that the vapor pressure of solvent in a solution could be given as 1 minus the mole fraction of solute in solution multiplied by the vapor pressure of pure solvent alone. And from here, we can say that since we know the vapor pressure of our pure solvent minus our vapor pressure of solvent in solution is delta P from equation 2, we could start to rearrange this new expression down at the bottom to solve for solvent vapor pressure and solvent vapor pressure in solution. I'm going to distribute this quantity. So I'll have that the vapor pressure of solvent in solution is equal to the vapor pressure of pure solvent minus the mole fraction of solute times the vapor pressure of pure solvent. One more time, move this up a little bit so that we can see that this quantity minus this quantity can give us something of interest. I'm going to rearrange this equation one more time. I'm going to bring this whole thing over to the left-hand side, bring this whole thing over to the right-hand side. I'll have the mole fraction of solute multiplied by the vapor pressure of pure solvent is equal to the vapor pressure of pure solvent minus the vapor pressure of solvent in solution. We called this earlier delta P from up in equation 2. So we can say that the change in vapor pressure for our solvent, or the vapor pressure depression, is quantified as the mole fraction of solute multiplied by the vapor pressure of our pure solvent alone. This is a useful expression of Raoult's law. So let's work an example. Suppose that we're going to make a solution of biphenyl with the chemical formula C12H10 in benzene, chemical formula C6H6, that has a percent by mass of 35.0%. We want to know what the new vapor pressure of that solution is, given that the vapor pressure of pure benzene is 101 torr. Well, in order to solve for this new vapor pressure, we're going to have to calculate a change in vapor pressure for our solvent, which is equal to our pure solvent's vapor pressure, that 101 torr, minus the vapor pressure of our solvent in solution, and that's given as the mole fraction of our solute multiplied by the vapor pressure of our pure solvent. So I know this and I know this. I'd like to find the new vapor pressure of our solution. So we're going to need to know the mole fraction of our solute. Our solute is biphenyl, C12H10. To get our mole fraction of biphenyl, we'll need to know the number of moles of it, C12H10, and the total number of moles of everything in solution. That's C12H10 plus moles of benzene, C6H6. and all we're given is a mass percent of this solution. Remember that the easiest course of action when given a percent by mass is to assume that we have 100 total grams of sample. If we've got 100 total grams of sample, then 35.0 grams worth of that sample in this example would have to be biphenyl. We can convert that mass of biphenyl into moles by dividing by its molar mass, 154.20, to give us 0.227 moles of it. If 35 grams worth of this solution were C12H10 and the solution has a total mass of 100 grams, then that leaves, by law of conservation of mass, 65 grams of our solvent benzene left over that we can likewise convert into moles by dividing by its molar mass, which is 78.11 grams per mole, giving us 0.832 moles worth of benzene. Plugging all of that into our mole fraction formula, we end up with a mole fraction of our solute of 0.214. Now, we have the last missing piece of the puzzle in the equation up above, the mole fraction of our solute, and we should be able to solve for just the pressure of our solution. The vapor pressure of our solution is given as follows. Our pure solvent's vapor pressure minus it is our mole fraction of solute multiplied by our pure solvent's vapor pressure once again. We were given that the vapor pressure of our pure solvent is 101 torr. The mole fraction that we've calculated is 0.214, and the vapor pressure of our pure solvent, once again, is 101. Solve this equation for just the vapor pressure of our pure solution, and we end up with 101 minus 21.6 for a total of 79.4 torr. This is the new vapor pressure of our solvent benzene in solution.